Now, what we're going to do here, equal 4. All right. We're going to go back to finding our ratios in our triangle, so we're going to get away from the unit circle a little bit. Okay. So let's go back over my 3 basic ratios: the sine of an angle, the cosine, and the tangent. How do I find the sine of an acute angle in a right triangle? What? What's the sine of an acute angle? All right. Opposite over hypotenuse. All right. Cosine is adjacent over hypotenuse. Y'all need to know these a little bit better. Tangent is opposite over adjacent. Now, those, remember I told you, those are your 3 new best friends: sine, cosine, and tangent. Now, the other 3, which would be what? Cosecant, secant, and cotangent. How do I find the other 3? The reciprocals. All right. So what's the reciprocal of the sine one? Tell me the function. Cosecant. All right. And then cosine, what's its reciprocal? Secant. And then the reciprocal for tangent is cotangent. Now, what we're going to do here is I'm going to give you, or your problem is going to give you an ordered pair for an angle that terminates at that ordered pair. And what we're going to do is we're going to use a triangle to find all 6 ratios. Okay, look at example 4. I'm going to read it here. It says, find the values of the 6 trigonometric functions for the angle theta in standard position if a point with coordinates 5, -12 lies on the terminal side. Okay, now the way I show you how to do this is not by memorization, but by figuring it out by drawing it. Okay, so let's look and let's think about that point that they gave me. All right, 5, -12. All right, first thing you need to look at is not really where the point is exactly, because we're not going to be exact with it, but what quadrant would it be in? 4, right? Because you go what? 5 and then down 12, right? So I'm just going to draw an angle in the 4th quadrant. Now, what I'm going to do with this angle is make a triangle out of it. Now, it's really important that you draw your triangles right, okay? And so you always start off with the hypotenuse in whatever quadrant your point is. And then you make a right angle with the x-axis. Never do it with a y, always do it with the x-axis. Okay, now do y'all see how we formed the right triangle by doing that? And so I'm usually not going to write this point right here, but this is the point 5, -12. Now, the angle theta that we're talking about is always going to be in the triangle, and it's always going to be at the origin. Okay, now what we're going to do is we're going to use this ordered pair to label the triangle, and then we'll use our ratios in our right triangle to figure them all out. Okay, so let's think about this point right here. All right, how would we get there, like to actually get 5, -12? We go where? What? Right 5 and then down 12. Okay, so we're going to label this leg with 5, and this leg's going to be -12. So what's different about the coordinate plane is we can have negative values on our legs. Okay, I want you to think about it. What if I was in the 2nd quadrant up here? Then the x-coordinate would be negative and the y would be positive. All right. If I was in like the 3rd quadrant, the x would be negative and the y would be negative. All right. If I was in the 1st quadrant, x would be positive and y would be positive. All right. Now, notice for my angle what? We're going to have to find opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Notice what's missing. The hypotenuse. So we can find the hypotenuse there, right? Y'all find it real quick. Use your calculator real quick. 5 squared would be 25. -12 squared would be 144. So we'll get 144 equals, no, that's not right. 169 equals c squared. So c would be 13. Okay. Now, really and truly, we might ought to say they're plus or minus 13, but the hypotenuse, listen to this part, the hypotenuse is always positive, okay? So we're going to put a 13. So on my coordinate plane, the legs aren't always going to be positive, but the hypotenuse will, okay? Now, once we got the triangle drawn, the rest of it's stuff we've already done. We're going to find the sine, the cosine, the tangent, and then the reciprocals, all right? So let's see if y'all can kind of name it off for me. So what's the sine going to be? Negative 12 over 13. Y'all see where that's coming from? Right, opposite over hypotenuse. Okay, and now cosine is adjacent over hypotenuse, so that would be 5 over 13. All right, and then tangent is what? Right, opposite over adjacent, right? Negative 12 over 5. Now, the other three, all I really need is these, don't I? Okay, so for cosecant, what am I going to look at then? Right. And really, with the negative, I mean, it really doesn't matter where that falls. Okay, I just throw it in the front. All right, and so the secant, right, the reciprocal of cosine, right, 13 over 5. And then cotangent's the reciprocal for tangent, so it would be negative 5 over 12. Okay, so notice you started with an ordered pair, and you got the 6 different ratios for that ordered pair. Okay, now probably what's going to happen, your homework will ask you to do the same thing. Probably what I would do on the test is so that, well, it wouldn't take so long, is I'd probably just ask for one of those. Okay, the only thing is if I ask for one of these three, you would have to probably find one of those first. Okay, if I ask you for secant, you would want to find cosine first. Okay, all right, let's do another example like that one. Yeah, and it's just a way of figuring out the ratios by just drawing a picture. Okay, all right, let's try. Let me find the one I wanted to do. Yeah. All right, let's do this one. Let's say that we're going to do the 6 ratios for the ordered pair. Let's do negative 2, 6. Okay, now I'm going to try to give you some notes here about how to draw your triangles. Okay, so first thing when you're drawing your triangles, think of your quadrant first. Which quadrant? Right, second quadrant. Okay, so you're going to draw an angle in the second quadrant. Okay, now when you make your right triangle, what you always form it with the x-axis. Okay, and now where's theta? Where's the vertex always? Origin, right? Okay, now so this point right here that we drew to is negative 2, 6. Now I didn't draw it very accurately. I never do. I always just make them the same distance. So let's label the legs on my triangle here. So I went what? 2 this way and 6 up. So right here I'm going to label this one with negative 2 and then 6. Now for those ratios though, we're going to have to find the hypotenuse. Okay, if y'all find that hypotenuse real quick. So that'd be what? 6 squared plus negative 2 squared would be 36, and 4 is 40. So is it going to be 40? No, it'd be the square root of 40. So it'd be 2 squared is 10. Okay, now y'all talk to me. Do I need to show you some more work right there? Okay, and I'm assuming, if you're in this class, you know how to do the Pythagorean theorem. Okay, and you know how to simplify square roots. Now, all right, from here, It's really not that bad. It's just stuff that we're used to, just finding the 6 ratios. Okay, so let's see. We got sine, cosine, tangent, cosecant, secant, cotangent. I need a little stamp that has that. That would really rule. If I had a stamp that labeled all those 6, stamp it and be done. Now, I would give you one too, but I don't have one. Now, here we go. Sine. All right, how do we find sine? Opposite over hypotenuse. All right, so 6 over 2 square roots of 10. Now, got to rationalize it, but probably be better to do what first there? Yeah, simplify. What 6 over 2 would be 3. So it'd be 3 over square root of 10, which would give me 3 square roots of 10 over 10. Rationalize it. When you're multiplying the numerator and the denominator by square root of 10. All right. 3 times square root of 10 is 3 square roots of 10, and square root of 10 times square root of 10 is 10. All right. Cosine. All right, yeah, negative 2 over 2 square roots of 10. Now the 2's will go away. Now that's not going to be negative square root of 10. It would be negative 1 over square root of 10. All right, let's rationalize it. So it'll be negative square root of 10 over 10. All right, tangent. Now, on some of these, you could do this. Really, all you have to find is sine and cosine. What's another way I could find tangent beside my triangle? Even the triangle's easier. What's tangent, really? Sine over cosine. So I could take this and divide it by this, which would be pretty nasty. But you could do it that way. Now, it's easier to do the triangle. Right, so tangent is just what? Opposite over adjacent. All right, 6 over negative 2, which would be negative 3. Okay. Now, when I do my reciprocal ones, I'm going to be smart about it. Cosecant is the reciprocal for sine. Now, instead of doing the reciprocal here, yeah, we're going to back up a step and do that one. Y'all see why we want to do the reciprocal with this one? What's going to happen when I do the reciprocal down here? You're not going to have to do what? Right, you're not going to have to do anything. You're not going to have to rationalize. Okay? All right, so for secant, instead of doing the reciprocal here, let's go here. So that's just going to be negative square root of 10. And then the cotangent, the reciprocal of negative 3 would be negative 1/3. Okay, now that's my way of doing that, and my way of doing it is more of a let's just figure it out. Now, the way the textbook shows you is they use variables called x, y, and r, where r sort of represents what you call the radius. And you could find them this way, but then what you have to do is you have to memorize those ratios. Okay, in trig, you have to memorize a tremendous amount of stuff. Okay, I mean, that's just the way it is. So if I can figure it out by drawing my triangle instead of memorizing, I'd rather figure it out than memorize it. Okay, it's a lot easier to figure it out from the triangles. And I've asked a lot of teachers that, and they kind of feel the same way. It's a lot easier drawing triangles. Now, let's do this. We're going to flip it around a little bit. Instead of giving you an ordered pair, I'm going to give you a ratio and the quadrant. Okay, and this is, I'm going to do example 5 here. Okay, it's on the next page. All right, so suppose theta is an angle in standard position whose terminal side lies in quadrant 3. Okay, so we're in quadrant 3. So let's draw our triangle. Quadrant 3 would be down here somewhere. Okay, so I drew the angle out in quadrant 3. Now let's draw the triangle. So I'm going to go to the right or up? Yeah, up. We always form it with the x-axis. Theta is always at the origin. Now, we're in quadrant 3, and it says if the sine of the angle theta is -4/5, find the values of the remaining 5 trigonometric functions of theta. Now, without doing anything, you should be able to tell me what cosecant is going to be. -5/4. Okay. But now, as far as what cosine is, and secant, and tangent, and cotangent, this is where I'm going to use my triangle. Now, I'm going to use my sine ratio because I'm not too familiar with cosecant. The sine ratio is what? Opposite over hypotenuse. Now, the trickiest thing about all this is what to do with the negative signs. Okay, when you have a negative sign, that negative sign is either going to go to the numerator or the denominator. Now, if we say that this is opposite over hypotenuse, let's see, this would be 4, this one would be 5. Now, which one would be negative, though? The 4. All right, let's go over why. Look, what we said, the hypotenuse is always positive. And what makes sense about this being -4? It's going downward. Okay, so always make like extra careful about your signs here. Now, let's find this leg right here. Okay, so we can call that what? A squared. Okay, so we can say a squared plus 16 equals 25. I'm going to subtract 16. That's going to give me 9. And we'll take the square root. And now really it would be, since I'm on the coordinate plane, I'm going to say plus or -3. And now what I have to do is figure out this 3 right here. Would it make sense if it was positive or negative? Right, negative, because it's going to the left. Okay, so on the legs in these problems, you have to be extra careful about your signs. Okay, that's what people miss on these, is the signs on these. Now, we can find the other 4 ratios, can't we? All right, so let's do what's missing now. Cosine. All right, secant. If y'all want to pair those two together, that's probably pretty smart. And then tangent and cotangent. All right, so let's see. Cosine is adjacent over hypotenuse, so that would be -3/5. All right, secant would be the reciprocal there, so just -5/3. Tangent is what? Opposite over adjacent. Now notice what's going to happen though. It's going to be positive because you have a negative over negative, so it would just be 4/3. And so now cotangent is just going to be the reciprocal of that. All right, 3/4. Now, so, I really put a lot of emphasis. I told you, be really careful with your signs. Okay. Now, here's another way to check my signs. All right. Remember our mnemonic? All what? Seniors take calculus. Hopefully, all seniors will be going home because of sleep. All right. Now, let's see. So, we're in the third quadrant, right? So, what did the T for tangent tell me in the third quadrant? That tangent should be positive. Now, is tangent and cotangent positive? All right, are the other 4 negative? Yes, got it right. Got my signs right anyway. Okay, so your little mnemonic here can really save you if you make a mistake with your signs somewhere. All right, let me do another one, and this time we'll do one that don't work out as nice. All right, let's see. All right, let me say we're going to be in quadrant 4, and I'm going to tell you the secant is square root of 29 over 5. Really nice numbers there. All right. Now, so let's see. Let me draw it. I'm in quadrant 4. All right. Now, if we know secant, then we should know what else? Cosine. So cosine will be 5 over square root of 29. And now rationalize would be 5 square root of 29 over 29. Now, a lot of times in trig, what you have to do is you kind of have to decide what number is going to be nicer to work with. I mean, this is going to be my answer, okay? But what's nicer out of the two if I'm going to label my triangle? This one, okay? So that's the cosine ratio that I'm using. Now, let me draw my triangle. This is my theta. Now, if I know cosine of theta, I know the opposite, and I know the hypotenuse. No, no, I said it wrong. What's this? Not opposite. Adjacent over hypotenuse. So right here, this side's going to be what then? 5. See what? Adjacent over hypotenuse. And so the hypotenuse would be square root of 29. Now, to find the other 4, we're going to need this leg. Okay, so we can use the Pythagorean theorem to find that leg. So we say 5 squared, which would be 25 plus b squared equals. Now, what would square root of 29 squared give me? 29, right? It would just pop the square root off. Okay. Now, so we subtract 25 from both sides. That's going to give me 4. All right, we'll take the square root. And so we need to think it could be positive or negative 2. Now, look at where the leg is. It's negative 2, right, because it's going downwards. So signs are really, really important on your legs. Okay. Now, we got secant and cosine. Let's name the other 4. What's left? All right, sine. So probably what we'd name right after it would be cosecant. Okay. And then tangent and cotangent. All right. So let's see. Sine is what? Opposite over hypotenuse. All right. So it'd be negative 2 over square root of 29. So it would be negative 2 square root of 29 over 29. Now, when we do the reciprocal of sine to get cosecant, right, we're going to do this one because we won't have to rationalize when we flip it. So it's going to be negative square root of 29 over 2. All right, tangent is what? Opposite over adjacent, so negative 2/5. So cotangent would be the reciprocal, yeah, negative 5 over 2. Now let's check it. I'm in quadrant 4, right? All seniors take calculus. So which one should be positive? Cosine and secant should be positive. So all the rest of them should be negative. Are all the rest of them negative? Yeah. So if I didn't get all these negative, I missed a sign somewhere, and you could really just fix the sign pretty easily. So it's really, really important. That's what you miss on these is signs. Okay. Now, all right. You look on. We don't have time to do another one. All right. Look on page 297. So you've got some where you got an ordered pair, and then you got some like this where they give you a quadrant and a ratio. There again, there's other ways to do this, but when you draw a triangle, all you got to do is remember your ratios. You don't have to memorize anything else. All right, it's over there.